Hope everyone is doing great. Welcome to another video. And today we are going to start a new and important topic. And today's topic is bar bending schedule, which we call BBS, and to estimate the steel quantity in building construction. So, in this topic, we are going to discuss many important things. So, I have divided this topic into five sub parts, and we will complete this topic in 4 to 5 videos. So in today's first video, we are just going to introduce the topic, and then we will discuss about the history of bar bending schedule and the basics of bar bending schedule. And then in second video, we are going to discuss the hook length or cutting length of stirrups and then bend length. And then in third video, we will discuss the total length of bar calculation for different types of bar shapes. And then we will discuss the overlap length, development length in the reinforcement. And in last video, we will conclude the topic by solving some examples where we will learn how to prepare bar bending schedule for stairs, columns, beams, slabs, and footings, right? So in today's first video, we are just going to introduce the topic and we will discuss some history of bar bending schedule and then some basics of bar bending schedule, some important points. So let's start the first video. So introduction to bar bending schedule. So actually the word BBS plays a significant role in any construction of high-rise building, right? So BBS refers to, what is the abbreviation of BBS? BBS means bar bending schedule. So the question arises is, what is the use of BBS? Why we use BBS? And what actually is BBS? Got it? So in this video we are majorly focused on how and where to start and what are the basics. Apart from this, we can also learn in these 3 to 4 videos that what actually is bar bending schedule and its importance, and then basics of bar bending schedule, how to prepare a bar bending schedule, important rules while preparing bar bending schedule, what are the important points which we need to consider while preparing a bar bending schedule, and then what are the uses of bar bending schedule. So these are the important points which we need to focus. So the first of all, the important thing we need to know is that what actually is bar. Bar is any type of rebar which is used as reinforcement in RCC, and there are some types of bars. Few of them are mild steel bars, high yield uh, strength high yield strength bars, and TMT bars. These are three different type of bars which we use for reinforcement in RCC. Got it? So bar bending schedule is termed as calculation of total steel required for construction of a building. Got it? If we want to calculate the total steel which is required for the construction of any building or any other project where we are using reinforcement, that term is called BBS or bar bending schedule. We use steel to make concrete to be reinforced, and for tension requirements, right? For tension requirements, we actually use steel. But the question is, how much steel is required for constructing like 15 floors of building, 10 floors of building? So the question is that how much steel is required for any project? How much steel I need to order? All these questions are answered by bar bending schedule, BBS. So in bar bending schedule, the bars are organized for each structural unit. Each structural unit means either beams, columns, slabs, footing, and other components where we are using reinforcement. And detailed list is prepared which specifies the bar location, like bars in the footing, bars in the slabs, bars in the beams, bars in the columns. Got it? And then we do the marking of bars to identify the bar in accordance with the drawings. And then bar size, that means length of the bar which we are using. And then quantity, by quantity we mean number of bar used. And then cut length, then we will find the cut length of the bars. And then type of bend and shape of the bar in the reinforcement drawings. So these are the important points which we need to consider while doing the bar bending schedule for any project or any building. So let's look into the history of bar bending schedule. Actually, bar bending schedule was started in 1950s, and B.N. Datta is known as the father of estimation, right? He is known as the father of estimation, and he found this method of bar bending scheduling in 1950s. So from 1950 to 2021, lot of modifications and enhancements happen in our world. And as we know that in 1950s, the highest building which was considered high-rise building considered was three-storied building. But now we are constructing buildings with 200 plus floors, right? High-rise buildings. So there is a massive growth in the construction industry due to the vast increase in the world population, demands increased, facilities, more need for space, more construction. So in the early time in 1950s, B.N. Datta, who was the father of estimation, has given certain recommendations for the usage of steel in different components of buildings. But he didn't mention any value if we use more bars in a single structural member or not. But he has defined some values for different components like slab, beams, columns, and footings. According to B.N. Datta, he said that in slab, 1% of the total volume of concrete is covered by steel, that is for slab. And for beams, he considered 2% of the total volume of concrete as steel. And for columns, he considered 2.5% of the total volume of concrete as steel. And for footing, he considered 0.8% of the total volume of concrete. So these are the considerations at that time in 1950s by B and Datta. But things have been changed with the passage of time. So we cannot use these recommendations in 2021, right? However, we can consider these recommendations for small projects, but when it comes to high-rise buildings or huge projects, we cannot consider these points. So with the passage of time, things have been changed. So we need to do detailed bar bending schedule. We need to make a detailed bar bending schedule to find out the accurate and correct quantities of steel for any project or any building. Got it? So this was a bit uh, information about the history of the bar bending schedule. So some of the basic points which we need to consider while doing the bar bending uh, scheduling. The first thing we need to know is that standard length of a steel bar. What actually is the standard length of a steel bar? The standard length considered is 12 meter or 40 feet. In feet it is 40 and in meters it is 12. Got it? And the second point is what is the formula we are going to use to find the weight of bar or unit weight of bar, steel bar. That is d squared divided by 162. What is d? D is the diameter of bar, and what will be the unit of the diameter of the bar? We will consider millimeter. as the diameter of the bar, unit of the diameter of the bar. So D is the diameter of the bar in millimeters, and this is the formula which we are going to use to find out the weight of the bar or unit weight of the bar. Let's consider an example. If length of a bar is 12 meter, we have given a bar which has a length of 12 meter, and the diameter of the bar, that bar is 10 millimeters, 10 bar, and its length is 12 meter. We need to find the weight of the bar. Got it? So for weight of the bar, we have the formula d squared divided by 162, right? And we already have the diameter of the bar, which is 10 We need to put the 10 in place of d. By solving it, we will get 0.61 kgs. This is the unit weight, right? This is the unit weight. Unit weight means this is the weight of 1 meter length, only 1 meter length of that 10 bar. But in example, they have asked us to find the weight of 12-meter bar. So we need to multiply that 12 with this unit weight, which is 0.61 kgs. And then by multiplying that, we will get the total weight of the 12-meter bar of 10 diameter, which is 7.4 kgs. Got it? So this was an example how to find the weight of a bar. The next important point which we need to uh, keep in mind is density of steel. The density of steel is 7,850 kg per meter cube. So these are three important points which we need to consider while doing the bar bending scheduling. So that's it. This was the introduction of the topic. So in coming videos, we will go into the depth of the topic. So for today, we are going to stop here, and in next video, we will come up with the second part of bar bending schedule. So thank you so much for listening. See you guys in next video. Till then, goodbye.